Hello everyone, and welcome to Jam Academy. The objective of this lesson is to talk about the rate at which work is done, the meaning and the implication of the rate of doing work. By the way, work is the transfer of energy when a force moves its point of application. As a matter of fact, the work done is positive if energy is transferred into a system, and negative if energy is transferred out of a system. But in the nutshell, work is simply the transfer of energy from one system or from one object to another, and that's as simple as it gets. Now, when you look at the definition and the implication of work, we do not talk about time. We do not talk about the rate at which work is done. Now, the rate at which work is done is called power. The word power is used in our daily language. It could mean force or energy. When someone says that he or she is more powerful, they may mean that he has a lot of energy or he's exerting a lot of force. But the meaning of the word power, the meaning of the word force, and the meaning of the word work are very precise in physics, and they're completely different. The rate at which work is done is called power. Let me say that again. The rate at which work is done is called power. Now, if work is the transfer of energy, then we can define power as the rate at which energy is transferred into or out of a system. Now, remember this. Whenever work is done, energy is transferred. Let me say that again. Whenever work is done, energy is transferred. This implies that power can also be defined as the rate at which energy is transferred into or out of a system. Now, the very first thing that I would like to talk about is average power. Average power. So average power is simply defined as the average work done divided by the time it takes to do that work. As a matter of fact, average power is just delta W divided by delta T. This defines the average power of an object. Remember, work is defined as the rate at which, work is the transfer of energy by a force or an object onto a system or from a system. So we can define average power as the average transfer of energy divided by the time it takes for that energy transfer to occur. Now, let me ask you a question. Suppose you have two students, one with a mass of let me say both students are identical. By that I mean they have the same mass, 50 kilograms. Which of these two students is more powerful? The one that takes 20 minutes to climb up a flight of stairs, or the one that takes 15 minutes to climb up a flight of stairs? Remember, average power is the average work done divided by the time taken. So if you take less time to do more work, that means you are more powerful. But if you take more time to do the same amount of work or less work, that means that you are less powerful. So the word power is used to quantify the rate at which work is done. Now, if you walk from point A to point B and you take about a minute to walk from A to B, and somebody takes about 20 minutes to walk from A to B, now you will do the same amount of work. The both of you will do the same amount of work, but one person will be more powerful than the other person. The more powerful you are, the less time it takes for you to do the same amount of work. So in this particular case, let's calculate the average power. Now, the work done the average work done is going to be equal to the force multiplied by the distance moved multiplied by the cosine of the angle between the force and the displacement. Now, when you are climbing up a flight of stairs, I want to submit to you that if this is your weight mg, you have your normal force acting upwards. Now, you realize that if you're climbing up slowly, the upward force that the ground exerts on you is balanced by your weight. So effectively, the work done by that upward force is equivalent to the work done by your weight. So we are going to have here mg multiplied by that distance h cosine of you remember you're going upwards, weight is acting downwards, so it's cosine of 180 degrees. So this is just going to be equal to negative mgh. Hence, the average power P average, which will be equal to delta W over delta T, will be equal to mgh. If you notice, I've taken away the negative signs because power is a scalar quantity. So this is going to be equal to, the mass is 50 kilograms. I'm going to take G as 10 meters per second squared. This is 200 meters. All divided by the time taken. This is 20 minutes. So we're going to multiply 20 by 60 to convert from minutes. This takes care of that. 2 here, 1. So we have here the average power P average will be equal to 50 multiplied by 10 divided by 6. That's 83.3. Now, the question I want to ask is, what is power measured in? What is the SI unit of power? What is the SI unit of power?